fluoride room, and this is for adding fluoride for oral health. What you do is, it's kind of interesting, it's a saturator. So what you do is you maintain a level of chemical between these two lines, and it gives you a constant solution, concentration. And so then this gets pumped as the water comes out. Again,
so this is a liquid product that's brought in?
No, it's actually a powder.
This is a powder?
Yeah, it gets added, it gets weighed and added. Actually, no, sorry, it doesn't go in added. The operators just maintain the chemical level between those two lines. And the other system is a safety thing. It just wasn't safe.
Right.
And here again we've got these aren't powered, but we've got the pump control. So if they run in hand, they'll time out, and they're really made to be running auto.
There seems to be more processes going on here than there was originally in the plan. So it's more elaborate than it was before. But it's
easier to
probably
run.
easy to work with because it's all controlled better.
It is, and the state requirement is flow pacing. So based on the flows, there's different flows. The coagulant chemicals, the chemicals that go into sedimentation basins, are paced off the influent. Now, as you go through the filter, a certain amount of water goes to waste as you clean the filter. Now, the chemicals that this is a finished chemical. The ammonium sulfate is a finished chemical. The hypochlorite, the bleach, gets added in the clear well, so that's not as it's going out the door. So those are the finished chemicals are more based on the plant effluent because it's different because we're wasting through the filters. Right. The only different chemicals are really is the ammonium sulfate, chloramines, and we're going to be adding an orthophosphate. It's in. That is for corrosion control.
Is the pipes clean in the system?
Well, there's two things. We all know that Gloucester has an old distribution system with a lot of cast iron pipe. And when you with the higher organic levels last summer and the warm water and all the material in the pipe, the chlorine gets consumed. So with the chloramine, it allows a longer lasting disinfectant. It has some properties that it can go after the biofilm. It's going to give us two things. It's really going to help us to maintain disinfection, and it's also going to reduce the total trihalomethanes, the TTHMs, which I haven't been happy about having to issue those notices. But the good news is we're going to be in good shape. We're not going to need to issue them.
We're on the other
side now. The other thing that the chloramines do for us is in 2013 we go to stage 2 disinfection byproducts. Right now, say I have 4 sample sites. It's an average of those, and then that's over the quarters. We've just got done 2 years of EPA water quality testing. Our new sites are the worst sites in the city. It's where we have the oldest water, the most challenged places. So those are, in 2013, those are our compliance points. And it's not an average, it's a compliance point at each location. So, there's some controversy, but really, there's 2 options in the distribution system. You can go with free chlorine, or you can go with the chloramine. Now, it's a debate. It's not a debate for me. It's what we are really required to do by the state. But the MWRA, 2.2 million customers, 1/3 of the people in the state of Massachusetts have been using chlorinated water since 1940. So there is controversy. Danvers just switched to chloramines recently. It's the problem is really for Gloucester, I think, is to operate West Gloucester in the summer with clear water, over here in the winter with less color when the organic levels are down. So we're trying to manage reservoir, manage how we know the seasonal water quality varies, and to really produce the water with the least amount of organics we can.
Right. So it's maintaining the whole system
yes.
instead of just
and
one system at a time.
And that's the key. It's not just the plants. Mike Hale has instituted flushing, and with flushing, that's going to be a constant. You've got to keep the water fresh. One of the other projects that we're going to move forward on is to put mixing systems in the tank. The Plum Cove tank needs to get painted, and one of the things you have to do is by having a mixing system, you keep the water fresh.
Right.
And you just stay on top of things.
It doesn't get stagnant.
It doesn't get stagnant, and that's the issue. You get the old water, and then you can lose the residual.
And then also talking about putting another level on that?
No, we looked at the pressure. That was previous. We thought that might have been a good idea, but if you go much higher, there's a few residents at the high end, and they may have bladder tanks to boost their water anyway. If you go much higher, the people on the low end, you're going to start having pressures greater than 100, potentially greater than 100 psi. So then you can almost start blowing up services. Pressure is, and based off studies that the consultants have done, the pressures are fine. It's really what we kind of need to do with the Plum Cove tank, which has been a challenge, is on the trunk line heading up the Plum Cove when it's isolated. What we're planning to do is install a valve, and what that will be controlled by radio. And what that will do is when the Plum Cove tank fills, it'll signal that valve to close. So the valve will close. Then the Plum Cove tank will drop up, say 5 feet, and then the whole key is to circulate the water through the tank. Right now the Plum Cove tank just kind of maintains a level and floats on the system. By exercising it, and then you bring the water level down, so you come down 5 feet, then the radio signals for it to open, it opens and fills up again. So you constantly do that.
Constantly moving the water.
It's what you have to do. And so I just met with Mike Hale and just met with the mayor this week. And, that's the next phase. This is phase 1, phase 2, and I'm calling that phase 3.
How often